ว่าที่นี่มันแค่แบบมันทำทั้งเป็นที่ฝึกของโลกมันเอามาตัดไม่ถ้าถาม financial container สองนี้เขาถามมันต้องบอกว่าเปิดไซส์เท่าไหร่แต่มันก็ไม่ได้บอกว่ามันไม่ได้บอกว่าไซส์เท่าไหร่แต่ว่าของมัน
we should start then. Okay, so because I think about 10 students show up now. Hello. Okay. So today we're gonna keep talking about how to do the differentiations. So we're gonna do more about the higher order derivative and the chain rule นะครับ So let me remind you from Monday first. So from Monday we are talking about how to do the derivatives. So for function of two variables c equal to fxy, so we can take derivative in two ways. So the first way we're gonna do the derivative with respect to x, and the other one is we're gonna do derivative with respect to y. When you do the derivative with respect to x, so you fix y to be constant, and then when you do derivative with respect to y, you fix x to be constant. Today we're gonna start from taking a look at page 8 in the slides. So this is the interpretation of partial derivative. So you know from calculus 1 that if you have the curve y equal to fx, this is from calculus 1. Calculus 1. So you know that if you are looking at one point and then you looking at the tangent line, the blue one here, this is the tangent line to the curve C at the, let's suppose that this is the curve C, right? So the tangent line to the curve C is the blue one, and in calculus 1 we know that the slope of the tangent line, this is going to be the derivative, right? The slope of the tangent line, slope of the tangent line, this is the derivative at the point A. So let's suppose that the point here, the touching point is AB. This is the thing that we learned in calculus 1. But now in calculus 2, so you have a function of two variables. So what does it mean by partial derivative? So the idea gonna be the same. So we're gonna just trying to look at the slope of the tangent line, but what line it is for the two-dimensional function. So we're gonna take a look at the picture here. So we have fxy equal to 4 minus x squared minus 2y squared. This is the function that we have. So if you draw the picture of this function, so you're gonna get this one. So you don't have to draw it, but I'm just showing you the meaning of the derivatives by showing the picture. If you use computer to draw the picture here, so you're gonna get the picture like that. And then the derivative with respect to x, what does it mean? So the derivative of f with respect to x, this means that you're gonna do y to be constant, right? Y to be constant or y fixed. It means that you are looking at the plane y equal to y0. You fix y equal to y0. So it's gonna be the case that correspond to this picture. This is y equal to y0 is a constant, gonna be the plane here. Everyone, you can take a look at this picture. So the curve here is the curve 4 minus x squared minus 2y squared, and then when you take the derivative here, it means you cut this surface by using the plane y equal to y0, because this means that you fix y to be constant. So it means you fix y to be constant and then you cut it in 3 dimensions. So you're gonna get the trace here. So the trace, you're gonna have the trace here. This is the trace that you have from the cutting the surface by using the plane y equal to y0. And then after that, you taking a look at the slope of the tangent line to that trace. It's gonna be the meaning of partial derivative here. So basically, you looking at this is going to be your trace that you have. But now you just taking a look at the slope of the tangent line here. This is the slope of the tangent line to the trace that happened from cutting the surface by using y equal to y0. So this is the meaning of partial derivative with respect to x. Okay, we're gonna just summarize everything in slide number 10. So far so good. It's a little bit hard in terms of concepts because you need to know the picture of the surface, but actually the calculation is not that hard. So for example, I'm gonna move to page example 18 here. So I'm gonna just rewrite everything in terms of notation so you can see it much better. So you have fxy equal to 4 minus x square minus 2y square. So this is the function that I show you on the previous slide. If you take the derivative with respect to x here, 4 minus x square minus y square. So you take derivative, so you're gonna get minus 2x, right? And then after that, let's suppose that you have the function here. So you're gonna have a surface here in 3 dimensions. I mean, the picture is not to scale, so I'm just drawing the picture like randomly. X is there, C is there, Y is there. But what happened is, let's suppose that I plug in y equal to constant because I just want to know what is the value when x equal to 2 and y equal to 1. So it means I'm gonna get negative 2 times 2 here, which is negative 4, right? It means that when I cut this thing by y constant, right? So x-axis is here. So I swap x and y here again one more time. Should be x, this should be y. So when I cut y equal to 1 here, because y is fixed, it means that I cut here with y equal to 1. So it's gonna be super hard when you draw it without the picture from the computer. But it's actually you trying to cut this thing by using the line y equal to 1. You cut it so you get the trace here. Does it make sense? So you actually use the plane to cut it here. Just cut the surface by using the plane y equal to 1. This is what you do. You just use a plane y equal to 1 to fix and cut it. And what happens is when you cut it, you're gonna have the trace here. The thing that happens here, this is called the trace from cutting the surface with the plane y equal to 1. And then you're looking at the slope of the tangent line to that trace at the point x equal to 2, y equal to 1, and c equal to something. Because when you plug in 2 and 1 here, so you're gonna get the value of f here. So the picture gonna be super hard to draw, but actually this number, this is the slope of the tangent line to the trace t, where t is the trace from cutting the surface fxy with y equal to y0. This is the meaning of x0, y0 here. So if you differentiate with respect to x, it means this is the slope of the tangent line to the trace t, where t is the trace from cutting the surface fxy with y equal to y0. It's so long here to memorize, but actually if you understand the picture, you're gonna see that the idea of the derivative interpretation is that you have the surface and then you cut it at one constant x or y. Well, I mean, if it is y, you cut this way. If it is x, you cut this way. But yeah, once you cut it, so you're gonna have a trace that happen here, and then the slope of the tangent line to the trace is gonna be the partial derivative. So with this complicated picture and notations and definition here, so we are not going to use it a lot because it's hard to see what does it mean by this slope of the tangent line. So we know that it exists, that you can interpret it, but it is not like meaningful compared to calculus 1, because once you know the slope of the tangent line, you cannot pick it up and use for something else. So we just know that it exists, but for the application, we don't have application on this one. Okay. This is not going to be the main thing that we're going to learn for calculus 2, but you should know that we can interpret it the same thing as calculus 1. Okay. Right? The better picture is here. The better picture is here. So you start from the surface and then you just cut it at one plane. And then once you get the trace, you look at the slope of the tangent line of the trace. This is a better picture from the computer. Okay. Alright, that is the slope of the tangent line. So let's go to the part that is going to be more tedious calculation. Higher order derivative. So once you know how to take derivative, you can do it one more time. This is called the second order derivative, and this is the notation. So the second partial derivative of f. So once you differentiate with respect to f with differentiate with respect to x, so you can do it one more time. It's gonna be fxx or fxy. This notation, you're gonna read it from left to right. This notation, you're gonna read it from left to right. Okay. Hold on. This is going to be left to right. So you can use fxx, fxy, fyx, and fyy. But if you use this notation, you're gonna read it from right to left. This is because you do the thing in parentheses first. So if you do differentiate f with respect to x, and then you do with respect to x one more time, so you're gonna get differentiate with respect to x 2 times, and this is the notation. So for the one that I highlight in green here, so you're gonna do it from right to left, but the one that I highlight in blue, light blue, this is going to be the one that it's from left to right. It's simple that way. So what you do is, when you start from the function f, take derivative one time. It's still a function of x and y, so you can differentiate one more time. And then you can keep going with more than 2 order. So if you want to do, if you see the notation something like differentiate 3 times of the function f, curl x, curl square y. Here, this is actually mean you do y first, and then you do y one more time, and then you do x. So when they let's squeeze the notation, it's gonna be on the top part, differentiate 3 times, and then curl x, curl square y on the bottom. No, not curl square y, sorry, curl y square. Y square. So this actually mean you trying to do the derivative with y first 2 times, and then you do x after. So this is the same notation as fyx. Does it make sense? So when you do the higher order derivative with the notation curl, you do right to left, but when you do the standard notation with the subscript, so you're gonna do left to right. And now you can looking at the examples. Okay. Good. Okay, let's start from the basic one. What is the partials? What are partials? Second order partial derivatives of fxy equal to y times e to the xy plus x cubed y squared minus 10. So this is a function. And then plus that. And then minus 10. This is a function. So when you do second order derivative, you're gonna do f subscript x first, and then f subscript y. When you do it, you can do fxx, fxy, fyx, and fyy later. So you can do it later after. So we're gonna start from f subscript x. Differentiate with respect to x, you will y as a constant, so y is constant, and then you differentiate e to the xy, so you're gonna get the same thing, which is e to the xy, and then you differentiate with respect to x, so you get y. Does it make sense? And then you keep differentiating, so you get 3x squared y squared. This is f subscript x. And then f subscript y, this is going to be the thing that you use a function that is given over there, and then you differentiate with respect to y. So you have to use product rule for this term. So it's gonna be y e to the xy times x, and then plus e to the xy. This is by the product rule. And then after that, plus differentiate with respect to y, so you get 2x cubed y. Well, you need to simplify a little bit for, the next step. It's going to be easier if you simplify it. So you're going to have y squared e to the xy plus 3x squared y squared here. And here you're going to have xy e to the xy plus, you can do xy plus 1 if you want to, xy, I'm not going to do xy plus 1 because just keep it here, because the next step you're going to differentiate one more time. It's going to be more tedious. Okay. All right, so this is the first derivative. This is the second derivative. Do you need like multiple choice questions on the final? So like I can give you a function, the easy function, and then you can just differentiate with respect to x. But I mean, like if it is a multiple choice, so you can, it's gonna be easier for some of you who like want to double check that your answer is correct, because there must be an answer in the multiple choice. Yeah, maybe we're gonna do multiple choice about 20%.
How the calculation, the calculation process count or not?
Well, I mean, like we're gonna do show your work about 80%, but about 20% it's gonna be some easy question. You can just pick the one that, so that way make sure that you get like the easy question correct, because sometimes you like have a hard time to double check your work that this is the correct, but I mean all right, so we're gonna differentiate one more time now. F differentiate 2 times with respect to x, so it means you carry this one that I put the arrow sign here, you diff one more time. So here you're gonna get y square constant, so you get e to the xy, and then you differentiate one more time, so you get y, and then plus the 3xy squared here, so you're gonna differentiate with respect to x, so you're gonna get 6xy squared. So you have y cubed e to the xy plus 6xy squared. Okay, this is actually fxx, and then we're heading to the next one, which is fxy. So you're gonna use the same thing in the box here, but now you take another derivative, but this time with respect to y. So you have to use the product rule here and then differentiate here. The product rule for this term, so you're gonna get y squared e to the xy x, because now you differentiate with respect to y, and then plus e to the xy 2y. Okay, and then now plus the next term is gonna be 6 xy 6x square y. This is actually the answer for fy xy. And then now you can do fyx, which is this one now, the one that I arrow in purple, and then you take this one, you differentiate with respect to x. So first of all, you need the product rule, right? So you're gonna need the differentiate with respect to x, so you keep y constant, and then you have x e to the xy, and then one more y, and then plus e to the xy. And then the second term, you differentiate e to the xy, so you're gonna get e to the xy, and then x, y, sorry, y, because you differentiate with respect to x now. And then the last one, you get 6x squared y. Once you simplify, you're gonna get this term is y e to the xy. This term is y to the xy. So you can group it up to 2y e to the xy. The first term is y squared e to the xy times x. Right, and then plus 6x squared y. What you can observe here is that if you take time, you can do it because it's just the basic calculation, is just extend it into dimension. But what you observe here is that this one, number 1 and number 2, they are the same. So this and this, they are the same. So it is a case that is fxy always equal to fyx. This is our question. So is it going to be always that when you differentiate x first and then followed by y, and y first followed by x, do they equal, or it's just an coincidence? So we're gonna have the theorem on the next page to check to show you that it is not always the case that they are actually the same, but you need some condition to make sure that they are the same. Let we do the last one very quick. So we need fyy. So from here, the last one is fyy. The color is like we need the darker color here. So fyy, this means you take that one in the box and then you do derivative one more time with respect to y. It's going to be the tedious one, x times y e to the xy times x, right? And then plus e to the xy. That is the first term here. You keep x, and then y e to the xy times x, and then plus e to the xy, differentiate y, you get 1. And then e to the xy here, you differentiate, so you're gonna get e to the xy times, differentiate with respect to y, so you get x, and then plus 2x cubed y, so you're gonna get 2x cubed y, so you're gonna get 2x cubed. Okay, makes sense? So many calculations here. Alright, so we're gonna continue the next page on example 20. Example 20, this is from the book. When you do the 4-second partial or 4-second partial derivative of the function f. So with another example, you have the same pattern that this and this, they are the same. So this is f actually yx. This is actually fxy. So you suspect that maybe fxy and fyx, they are actually equal because you use this function that they given in the book here. So you also get the same number here. The one that we just did before with this function, also they are the same. So the good reason is if they are actually the same, we can compute just one and then we say that it is equal to the other one. So it's gonna be shorter time to compute. But the theorem is here. Theorem 12.4 in the book say that when you have the condition, some good condition, you can conclude that fxy equal to fyx. So they said that assume that f is defined on the open set D, subset of R square, and fxy and fyx are continuous throughout the domain D, then they are actually equal of at all point D. So the keyword is continuous. So basically fyx and fxy, they're gonna be equal to each other if they are continuous. So if you see continuous functions, so they are actually the case that you can swap the derivative. The order of the derivative, you can start from x first or you can start from y first, it doesn't matter. So what does it mean by continuous? It means that if you see something like polynomial x to the n, or if you see something like exponential e to the x or e to the y, or this is y to the n, for example, or you see trigonometric function such as sine, cosine, for example, this is all, they are all continuous, right? Sine and cosine. This is the case that you can actually swap here. The thing that you know for sure that it is not continuous is the case that here fxy equal to something and something here. Like you have the parenthesis here. This is the case that not sure this is continuous or not. Not sure about the continuity. This case you have to be careful and compute fxy and fyx separately. But if you see continuous functions, it should be okay to do only one, and then the order x, y, and yx, they are the same. Okay. With this idea, so if you go back to the previous example, you can compute just fxy. It's gonna be the same with fyx. Okay. All right. So questions. All right. So we're gonna move to the next one. So let's trying to do the proof part. So we're gonna do one question on the proof and then we're gonna move forward to the chain rule, which is the main topic for today. Okay. Example 20, given that logarithm fxy equal to log a square x square plus b square plus y square, can you prove that this equation is correct? So b square differentiate 2 times with respect to x plus a square differentiate 2 times with respect to y equal to 0. So let's do it here. So we're gonna have f differentiate with respect to x first. So differentiate that one, so you get 1 over differentiate log So you get 1 over a square x square plus b square y square here. And then now you differentiate one more time. Before that, you have to use the chain rule, right? So inside here, you get 2a square x square. Does it make sense? This is, you differentiate logarithm of some function here. So you get 1 over that function. And then inner function differentiate with respect to x. So you get here. It is actually 2a square x square over a square x square plus b square y square. And then now the question asks you to do it one more time because you need this term. So you're gonna do differentiate 2 times. So you use the same thing, the function that you have before, and then you take derivative one more time. So this way you have to use a quotient rule. Low d high minus high d low. Over low square. It's gonna be the tedious calculation here. We're gonna do the same thing with y. And hopefully that when you add them up and cancel a lot of things, so they're gonna be 0 as you want. So for y, you're gonna do the same thing. So you differentiate log. So you get this, and you get 2b square y square. Wait, is that right? Just x right here. Okay, sure. 1 second. So I need to change a little bit. So whoop, x here is gonna be low d high. Shoop. Give me a second. Shoop. Low d high minus high d low. Okay. So we're gonna differentiate this one. So this is already correct. So for the first derivative, so this is high, this is low. So we're gonna have low d high with respect to x, and then high d low. So it's gonna be differentiate that one. So you should get something smaller. So differentiate a square plus x square, a square x square plus b square y square here with respect to x. So you should get this term gonna be disappear because no x, but this term you're gonna have 2a square x okay. Well, we hope that at the end they should like cancel out something, but we're gonna keep it here first because at the end we expect something to cancel. So we're gonna continue differentiate f with respect to y. So once you did with x, so it already good. So y should be similar to x. So a square x square plus b square plus y square. But this time you have 2b square y. Right, so you're gonna have 2b square y over a square x square plus b square y square. And then now another quotient rule. So differentiate 2 times with respect to y. It's so tedious here. A square x square plus b square y square square. And then now on the top part, so you're gonna have low d high minus high d low. Okay. So what you have next is you can just compute the thing that you want now. So it's b square differentiate 2 times of f with respect to x 2 times plus a square differentiate with respect to f and then y square. So you can see that if you multiply this thing by b square, if you multiply this thing by a square, so this term and this term gonna cancel out. Why? Because if you multiply this thing to b square, multiplying a square, or not cancel out, it's gonna group it up, right, to 4. Because this is actually b square multiplied here. This is actually a square multiplied here. Does it make sense? And then this term and this term, they are the same now. So you can group it up. So when you group it, so you're gonna get now you're gonna get 4a square b square, a square x square plus b square y square. This is the first term. And the second term is 4. Well, we multiply this thing with b square now. So this is actually 4 times a to the 4th power x square and then b square. Okay. And if you do this thing, so you're gonna multiply it with a square. So you're gonna have, actually here you're gonna have 4a square b to the 4th power and then y square. And then actually if you pull out a square b square 4, so you're gonna get the same term. It uses a lot of algebra, but you're gonna give the same term. You're gonna have the same term. This is actually 0. Okay. So tedious calculation, but at the end you get the same thing, 0. Okay, next one we're gonna talk about the chain rule. So I know this is the super tough calculation because you have so many things to differentiate, because you have to use quotient rule and the function is not beautiful. This is a little bit ugly for you to differentiate, but well, if you take time, I'm pretty sure you can do it to differentiate functions. Now we're gonna continue the next topic, which is the chain rule. So
Can you go back to that slide? Please.
take picture ไหม Well, it's require a lot of calculation here when you multiply it with b square, and then when you multiply it with a square, and then you add them up, so you get 0 here. Alright, so let's talk about something new. So this is the chain rule. So the chain rule is that this is the chain rule in one dimension. So you have dy by dt equal to dy by dx times dx by dt. So the reason why we call it chain rule, because you have y is a function of x and x is a function of t. So when you differentiate y with respect to t, so you can do dy by dx times dx by dt. This is all the chain rule. You can imagine that the x gonna be the cancellation here. This is what we did in Cal 1. But now in calculus 2, you gonna always draw the diagram here. And once you draw the diagram, so you can set up the chain rule for 2 dimensions. So let's see how to set up the chain rule in 2 dimensions here. Ready? So this is the chain rule number 1. So chain rule in 2 dimensions, for example, you have f is a function of x and y, or c is a function of x and y, and then x is a function of t, y is a function of t. So when you draw the picture, it's gonna be you have c is a function of x and y, and then x is a function of t, y is a function of t. This is the diagram that you have. So if I want differentiate c with respect to t, so it means I have c here, I differentiate to t here. So there are 2 ways that you can do. So one way, like you can go to t by x. Another way you can go to t by y. So when you do it, it's gonna be dc. Take a look. You differentiate with respect to x first, and then dx by dt, right? And then plus differentiates with respect to y, and then dy by dt. But now because c is a function of x and y, so you have to use partial derivative here to make sure that, okay, this is just a partial derivative. So you're gonna cancel this, and then you do derivative. Okay, so with function of 2 variables, always draw diagram. We always draw a diagram. So to make sure that it is correct, we're gonna draw a diagram. So every time when you see the function, so you need to draw the diagram first and see how many ways you can go from the top part to the bottom part here. So if there are 2 ways, so you're gonna have 2 terms here. If there are more than 2 ways, like you have st here, so you're gonna have another term, because you're gonna have how many ways you can go to t. You need to count all the way to go to t, and then you add them up. So it's gonna be something like you cancel this thing, so you get dc by dt. Okay. All right. So for example, let's take a look at this example. So let's suppose that you have c equal to this, and then now x equal to sine 2t, y equal to cosine t. So when you actually do the question, you're gonna imagine that you have c is a function of x and y is a function of x is a function of t, y is a function of t. So this is actually the chain. And then when you do it, this one not given on the exam, so you have to create it by yourself, but it's super easy to create it because you can take a look at c is on the top, t is on the bottom here. So you can go dc by dt, you can go by x and by y. So it's gonna be here and here. And then once you have that one, so differentiate c with respect to x, you can do it. Differentiate c with respect to y, you can do it because this is a function. You know how to differentiate. And then dx by dt and dc by dt, you can actually do it as well because you have function here. And at the end, you plug in everything, so you get the answer. You plug in at the point you want, so you're gonna get the answer. So we're gonna just use this technique to do more examples. Okay, so this is the example from the book. So we're gonna take a look at the example that we do together in class. Okay. Before that, this is another bigger diagram if you wanna do something more on the chain rule. For example, if you have c, this time a function of x and y is a function of s and t. So if you want differentiate, take a look at this one. If you want differentiate c with respect to t, everyone, c is here, t is here and here. So it means you can go to t two ways. So it means you're gonna have dc by dx, co c by co x times co x by co t, because you go this way, the first one. And then plus the second way that you can go is this and this. So it's gonna be that. Okay. So let's do example now. So again, the technique is you always draw a diagram and then set up the chain rule from the diagram and then compute everything. Okay. So we're gonna start by, let's c equal to e to the x sine y. X is equal to st square and y equal to s square t. Can you find co c by co s and co c by co t? Okay. Let's do it. So we have c is a function of x and y. X is a function of s and t. Right? This is what you have. X is a function of s and t. Y is a function of s and t. C is a function of x and y. So if I want co c by co s, what would I do? So I'm gonna start by on the top part here, the bottom part here. So you observe that the first way that you can go from C to S is the blue one. The second way that you can go is the green one. So when you set up the chain rule, it's gonna be co C. Well, let's take a look at the first part first. Co C by co S, and then x by S. Okay, this is the first term. Correspond to the blue one, because this is the blue one. And then plus co c by co y times co y by co s. This corresponds to the second term here. Okay. And then you compute everything, so it's gonna be your answer now. So dip c with respect to x, so you're gonna get e to the x sine y. And then dip x with respect to x s, so you get t square. And then now co c by co y, so you're gonna get e to the x, dip side you get cosine, and then co y by co s you get 2st. This is the answer already. But if you want it to be more beautiful, you can replace x and y by s and t if you want to, but you can stop here technically. Makes sense? And then now differentiate c with respect to t. You're gonna do the same thing here. Okay. And then now co c by co x is e to the x sine y, the same thing as the top part, but co x by co t you get 2st. And then here you're gonna get e to the x cosine y, and then co y by co t you're gonna get s square. Is that okay? So everyone here, not that hard now. Shall we do like one more example and then we break, or you just want to continue? Break ใช่ไหม What ดูว่ามีคะแนนออกหรือจ๊ะทำไมทำหน้ากันเหมือนรู้ว่าคุยกันซะขนาดนั้น Okay, we're gonna do one more example and then we're gonna do like 5 minutes break for you to talk to like stretching about the calculation here. This is the case that you have general version. Always draw diagram again. Always draw a diagram. and then see how many parts. See how many parts from the top to bottom. Okay, this is a technique that you can use.
อาจารย์คะ do you give any like scratch point partial point for drawing an answer
อ๋อแน่นอนครับ ต้องให้อยู่แล้ว if you draw a diagram you yeah of course you get the first credit the first partial credit for the question but
better than nothing
exactly
alright so let's do one more example then so this is just the general technique for doing the chain rule นะ but I mean if you trying to do the memorize the formula it's gonna be super hard because you can see that you have so many subscript here so it's gonna be super hard to memorize but we always do the chain rule by the diagram it's gonna be a lot easier for you to memorize that way so taking a look at the question first which function is a function of what variable and then you draw a diagram and that should be good okay so one more and then we stop here before the break so example 23 I want you to use the chain rule to find the partial derivative here so start from C is equal to a function of x and y right because you can see here function of two variable right C depends on x and y now x is here and y here so x gonna be the function of s t and u here is s t and u so this is the first check once you get the diagram so you're gonna get the first part done so the second part is set up the formula so what is cos C by cos S so you have C here S here S here so it means that you can go this way and this way so it means you have cos C by cos X by times cos X by cos S this is the first one the second one is cos C by cos Y times cos Y by cos S this is the second one right and then this is already good this is the formula that you have this is the second check does it make sense and the last one you just need to compute everything and then you plug in the value here so it's gonna be the answer for that question so we're gonna start from differentiate C with respect to X so this is actually 4x cubed plus 2xy does it make sense and then x differentiate with respect to x so you get 1 this is super easy because it's actually t and u will be disappear and then here plus cos C by cos Y here is gonna be x square and then cos Y by cos S gonna be tu square is that okay for everything just doing one by one this equal to this equal to this equal to this and this equal to this and then now you plug in everything so some of you don't know how to plug in so s equal to 4 t equal to 2 u equal to 1 so if you calculate s t and u plug it back here so you're gonna get x and y as well so x gonna be 4 plus 4 minus 1 so x is minus 1 right and then y is gonna be s times t times u square so y is 8 so actually you plug in s equal to 4 t equal to 2 u equal to 1 x equal to negative 1 y equal to 8 so this is 4 times negative 1 cube plus 2 times negative 1 times 8 and then plus negative 1 square times t which is 2 and then u is 1 square so for sure this part is 2, this part is negative 4 plus negative 16, which is negative 20, right? Negative 16 plus negative 4 is negative 20, so it's actually negative 18. All right, this is the example. So we're gonna skip this part and this part because once you can do S, you can do the same thing with T and U, right? You just, for T, you just do this part, switch this thing to T, T, and T. For U, you're gonna do U, U, and U. This part, we're gonna skip it. Okay, so basically not that terrible for the chain rule. Draw diagram, set up, and then compute. Alright, so until 11:10, let's take 6-minute break and then we come back to learn 30 more minutes for today. นะครับให้เบรกพักใจก่อนนิดนึงนะครับ เพื่ออยากคุยเรื่องอะไรกับเพื่อน เห็นหันหน้ามองกันอยู่ โอเคสรุปก็คือเหลือแคลที่เป็นความหวังเหรอ ไม่ต้องหวังเยอะนะครับ
2.5เลยนะเว้ย
คำนวณไหมเอาไหมคำนวณแม่งเลยคนที่25ใช่ไหม25คนต้องการวันนี้ห่างเท่าไหร่เขามีตอนนั้นไปสอน6เขาบอกว่าเนี่ยเรื่อยๆคุณเลยแต่ไม่รู้กี่โมงตอนนั้นได้สอนอะไรนะตอนแรกคิดว่าประกาศแต่ประกาศวันนี้ศูนย์แค่5
แต่ว่าเท่าไหร่นะไม่ถึง10 69
ไม่ถึง10มี69คนจาก200ของคนไม่อยากโทรวิชานี้มันไม่ใช่แบบว่าถอนไปแล้วมันจะกลับมาทำใหม่ได้อันนี้มันก็โง่เหมือนเดิม
ตอนแรกคือมันเข้ามามี2ขึ้นมา
กูไม่ทำแล้วกูมาเลย
เป็นจะผ่านอีกเข้ามาลบอีก
มีใส่ติดตั้ง20 คนไม่ติดเพราะว่าไฟนอลอาจารย์ช่วยคุณต้องไม่รู้ไฟนอล
ลงคะแนนก่อนจ้า
ว่าไม่แบบไม่เกิน10อ่ะไฟนอล
ก็เหมือนเรื่องมอปลาย
มอปลายแตกวายมากเลยสำเร็จคะแนนที่มอปลายยอกโอ้โห
เครียดเลย เวลาไปแข่งกับ ISE แบบพวกเล่นกันละเราไม่เสียเปรียบตายหรอวะ CIPE มันขึ้นแค่รุ่นเดียว
ต้องชนะบายหลายอย่างด้วยเพราะว่ามันโซน
คือแบบว่าของ CIPE ของ BBA อะไรเงี้ยคนแม่งเป็นร้อยเราจะไอ้นี่มีแค่20 คนก็คือผัดตัวกันลงจนแบบว่า
ก็แบบฟิลครอบครัวอาจารย์
ว่าเห็นแบบว่าหลักสูตรอินเตอร์อื่นเขาคนเยอะกว่านี้เยอะเลยแถมมีสี
ก็ไม่ลงเยอะค่ะเลยชาย1 คน
ก็เลยแบบอันนี้ทุกคนต้องเล่นไม่มีตัวเลือก
อาจจะเล่นเทนนิสเก่งเล่นเทนนิสด้วย
กูลงเหมือนหน้าตบไก่กูไอ้เฮียกูลงแบบไม่เป็นไก่กำมืออยู่ลงลูกไก่กำมือต้องน้ำแป๊บลูกไก่กำมือภาษาอังกฤษแปลว่าอะไรวะกูขอร้องไอ้เฮียมันตรงตัวไหมเปล่า
บอลแรก
รวมมาแล้วจาน
ชอบโดดไม่ได้ขอยอดไม่ตกแบบนี้ยอดแล้วมีใครได้ข้อมูลเราต้องสั่งมงกุฎมามงกุฎพร้อมใส่ซับผ้า
เฮ้ยทำกิจวัตร
ไม่เอาต้องมงกุฎมาบ้าง
ไอ้ต้องมงถึงจับเลย
ค่อนข้างเครียดค่ะอาจารย์
วิชาอะไรเนี่ยแลบ
อาจารย์เนี่ยแหละ
แลบเหรอ
อันวิชาอาจารย์เนี่ยแหละ
มาเครียดวิชาเราแทน ไปถึงว่าพอวิชานั้นไม่ได้ก็เลยปล่อยเลยมาเครียดอันนี้แทนอะไรเงี้ยหรอ
แถวโอ้โหอะไรเป็นเต็มแต่แบบว่าถ้ามันออกดูไม่ยากนะ
ของประพานันท์นี่ต้องขอบคุณอาจารย์ใน SE นะ เพราะว่าคราวที่แล้วเรา ตอนแรกเราให้พี่ซีบวกนะ แต่อาจารย์ใน SE เขาเห็นแล้วเขาบอกว่าแบบคนเนี้ย B ได้เขาก็เลยให้ B
แล้วได้74อะ
ตอนแรกอ่ะมัน C บวกเพราะมันโดดจากเพื่อนแล้วอาจารย์ใน SE เขาเห็นเขาแบบคนเนี้ยขึ้นไป B ได้เพราะว่าเขา70แล้วก็เลยช่วย ต้องขอบคุณอาจารย์ SE นะเขาช่วยเธอ
มันได้74มันไม่สองคนมันได้4บวกปะ
ไม่กันเถอะไม่ของเรามันมีการบ้านไง ก็เลยต้องตัดสูงนิดนึงนะจ๊ะ
ตอนนี้ถ้าเทียบกับการมึงเอาเขาบอกหลังเลยแค่69
ทำไมคะแนนมันต่ำจังวิชาอะไรเนี่ย ของโลดลิ้นอ่ะนะ
ก็ของโลดไงจาน
ไม่แปลกใจแล้วทั้งนั้น
ตอนนี้จานเรียนกับจานโลดจานรู้สึกไงคะแนนสวยไหม
เอ้ยเราทำได้ เพราะว่ามันเคมีมันเป็นคำนวณ มันเป็นสารสัมพันธ์เคย โลดลิ้นมาทำงานตอนเราปี 1เขาแบบสอนรุ่นเรารุ่นแรกๆเลย
อาจารย์รุ่น58ใช่ไหมคะ
50ไม่58เรา
สูตรตอนนี้65นะครับบวกคนนี้
โลดลิ้น38
โอ้โหยังไม่เกิดเลย
38พวกกูเกิด4 คน
ไม่อะ
พวกกูยังเป็นแบบเทวดาตัวน้อยอยู่
ตายเลยวันครั้งที่แล้วอ่ะ
50คือปีเข้าเว้ยไม่ใช่ปีเกิดแหมถ้าจานเกิด50ตัวนี้ก็ให้ขวดเลย
ไม่แปลว่าอาจารย์เพิ่งจบไป
จริงใช่ เราจบมาเรากลับมาพร้อมกับโควิดอะ
กลับมาพร้อม
เรากลับมาไทยพร้อมกับโควิดอะ
กลับมาพร้อมโควิด
เรากลับมาไทยพร้อมกับหนีโควิดมากลับมาไทยหนีจากอเมริกากลับมาโอเคนะครับ we gonna learn a few more examples and then we can I have 24 25 26 and then we gonna end the chain rule here and then next week Monday we're gonna do max and min problems. Okay, so everyone taking a look at example 24. So we have GST equal to F s square minus t square minus s square. F is differentiable, so can you show that this equation is true? So this is actually confusing when you read the question. So this means that you have a g is a function of s square minus t square and the function of t square minus s square. So this is actually super terrible if you do the chain like this, right? Because you have s square and t square here. So the technique is that when you see the question like this, we're gonna change variable first. This is a little bit complicated here. So we need to switch the variable. Switch the variables. So something it's gonna be easier for this question. So we're gonna first delete this one. Name it different one. So we can name it x and y. And then now x and y. We define x to be s square minus t square. We define y to be t square minus s square. Now this time g gonna be function of x and y, and then y gonna be function of s and t. This is okay now. This look easier this time compared to you have g is a function of s square minus t square, and this is t square minus s square. You see that? So if you use the red one, this is a hard one because this is terrible. So we're gonna start from switching the variable to the easy chain like that. So it's gonna be easier for you to work with. So we construct x and y to be this one. So we can just get the simple chain like that. So every time when you see the question and you have something that is complicated over there in the circle, in the purple circle, you can switch the variable first. So it's much simpler, and then now you can apply the chain rule. So now let's do G by S. What is G by S here? So it's gonna be G is here by S here, S here. So it's gonna be G by X, and then X by S, and then plus G by Y. It's gonna be Y by S. Okay, and then now you differentiate G with respect to X, so you get G co G by co X. You don't know the G function, so keep it there because you have no way to simplify now. Differentiate X with respect to S, so X is here, so you get 2S, right? You don't know function G, so keep co G by co Y over there because you don't know it. But you differentiate Y with respect to S, so you get negative 2S. Okay. And then now if you multiply T to the function, you multiply T here, you multiply T here, you multiply T here, right? So everything gonna be co G by co X times 2ST minus co G by co Y times 2ST, right? So okay, this is the first part. We already did it. So the second one, the red one, S times co G by co T. We hope that we're gonna get the same term or like the subtraction of the previous term, so we can add them up, the green one and the red one, and hopefully you get 0. So S times this, okay, and then plus this, okay, right? Because from G to T you can go two way as well. And then now S times co G by co X, you don't know, you keep it. Differentiate X with respect to T, so you get negative 2T. And then co G by co Y, you don't know it. Co Y by co T, you know it, 2T. So you can see that they give you at the end co G by co X times minus 2ST. And then plus co G by co Y times 2ST. Which if you add them up, add the green one and the red one, it is equal to 0, right? Because this term gonna cancel with this, and this term gonna cancel with this, right? Make sense? So you add them up, so you get 0. So this is how to do this example. The technique that we learned from this example is when you see something inside here that is not just X and Y, it's more complicated, so switch the variable first, so it's gonna be easier. Okay, I'll let you jot down for this one. All right, example next one, 25. You done? Not yet. 25 ครับ ได้ยัง Okay, 25. Suppose that f is a differentiable function of x and y. F differentiable function of x and y. And then now you have g as a function of that and that. A little bit complicated. And then now you use a table the value to calculate g. Can we like I think this one is like way outside the content that we're gonna learn, so we're gonna this is another technique that we can define another variable and then you can use the chain rule. So we're gonna skip this question because I think this is not our main target for the class. So for the class we are not going to do the question like this. So we're gonna I think I forgot to like remove it from the slides. We're gonna do example 26, which is the long one for the remaining time. But this one, reading the value from the table will not be covered because I already deleted from the Thai version, calculus Thai, so I'm not going to teach it for the inter version as well. So this one, we are not going to ask you to read the value from the table for the chain rule. So this is not necessary. So read the value from the table, no. Reading the value from the table. This is not covered on the exam. Not covered. I should say not necessary. Not covered on the exam. Because we don't teach it for Thai student as well. So we already deleted this year. So reading the value from the table, we don't do it from the final. So what we actually want you to do is like I give you a function and then you should be able to take the derivative from the function, not from the table. Okay. The last one, number 26, this is the one that is super long and tedious. So we're gonna take a look at the last one. So it should take us probably 15 minutes for this question, the last one for today. So example 26, if c equal to x fxy continue a second partial or derivative, we have it, and then we have x equal to r squared plus s squared and y equal to r 2rs. Can you first find cos c by cos r and cos c squared by cos r? This is the one that a little bit tedious for part B. So you have to take a look, and because this one you take derivative 2 times, right, with respect to r and then r. Okay, let's do it. So c equal is a function of x and y, and then now x is a function of r and s. This is r and s. Okay, then now cos c by cos r, this is going to be cos c by cos x and then cos x by cos r, then plus cos c by cos y times cos y by cos r. And then now you do here cos c by cos x. You stop it here because you don't have the function. What is c? You don't have the function, so you stop there. But x, you have a function, so it's gonna be 2r. This is cos c by cos y. Y, you have the function, it's gonna be 2s, right? Okay. Now imagine that this is part A, good already. So now imagine that if you wanna take derivative one more time, so what happened? So you're gonna take derivative one more time of this one. Oh, not sorry, this is r, not theta. This is part B, this is part A. So you differentiate one more time, so it means that you have to do theta. Whoa.
I think you learn theta, na?
Yeah, I like trigonometry.
But not for me.
Not R, not R, it's R, sorry, it's R. Sure. Oh, I keep getting the same. Okay, R. Now it's gonna be differentiate this thing inside with respect to R. So it's 2R cos c by cos x and then plus 2s co c by co y. What would you do?
มันไม่แปลกๆอะไร
ตรงไหน this one
เอาตัวแขวนมาจากไอ้
this one
อันนี้ตัวบีหน่อยบี
เดล R แล้วก็เดล R สแควร์
อ๋อ
น่าจะเดลอาร์เฉย
โอเค sorry ใจลอยไงอยากเลิก okay here curl by curl r to that one, so you're gonna first need to plug in this thing inside here, and then now first you split this term and this term because this is a plus sign, you split them up, so you're gonna get curl by curl r, split this thing to 2r curl c by curl x. This is the first term. The second term gonna be curl by curl r 2s curl c by curl y. Does it make sense up to this point? So you have plus here, you split to two pieces. So the first one is here, the second one is here, and then we're gonna doing this one and this one separately. This is called number one. This is called the term number two. Okay, we're gonna start looking at the term number one on the next page. Okay, sounds good. So, okay, next page. This is example 26b. Sorry, 26b. We keep going 26b. So curl c by r, and then you're gonna do 2r curl c by curl x. This is the term number one that we have it before on the previous page. So what would you do on this one? So you have to use the product rule, right? Because this is actually taking a look. This is r, so we're gonna differentiate r. This is another term that you have to use the product rule. Curl c by curl x is a term depends on r as well, because if c is a function of x, y, and y, x is rs, y is rs, so curl c by curl x, this is going to be on the same level as c, right? The same level. So which mean here, once you apply the product rule, you can pull out number 2 first if you want to. Pull out number 2. And then when you do the product rule, so it's gonna be 2 times r. The product rule is gonna be differentiate this thing one more time. And then you keep this thing, and then you differentiate r, which is 1. Does this make sense? This is by the product rule. So it's gonna be r and this one, right? It's gonna be, this is the first term, this is second term, so it's gonna be keep the first term, differentiate second term, keep the second term, differentiate the first term. But this term, because curl c by curl x, this is actually on the top part because the same level as c. So you can apply the chain rule one more time. So it's gonna be 2r. So this is actually curl x, and then curl x by curl r, and then plus curl y by here, and then y by r, and then plus curl c by curl x. Okay, I'll let you jot down first and then I will explain later.
ไอ้ข้างหลังอะเคิร์ลไปเคิร์ลอาร์มันเป็นหนึ่ง
ใช่ Well, we can keep this thing first.
มันคือเคิร์ลคูณอาร์อีก
This is actually differentiate r with respect to r, so it is 1. So I will let you jot down first and then I will keep explaining this one. Because this is a little bit, this is why I say this is a heavy calculation. Because it's gonna be tedious when you see the product rule and then you apply this thing. Okay. So let's start from the first step to the second, the first line to the second line. This is by the product rule. You can take a note that this is the product rule because later on you probably forget. This is actually the blue one, the yellow one. So you get, keep the blue one, you differentiate yellow one, and then keep the yellow one, you differentiate the blue one. This is okay, right? For the product rule. For this to this is by the chain rule. Why? Because you can imagine that this term and this term, they are the same. This term to this term, they are the same. So nothing to do about the circle here to this circle. But R to be the same with R here. But just this term, this is the part that is a little bit complicated. This term to this term. This one to this one, right, is a little bit complicated. So what happened is you're gonna will curl C by curl X inside here as a function on the top. So if you feel like this is so hard, you can imagine that curl C by curl X, this is on the top level. This is a function of X and Y. This is a function of R and S. This is a function of R and S. So the top part here, you want to differentiate with respect to R. So you can go by X and you can go by Y. So it's actually mean the thing inside here, no matter what it is, you're going to differentiate that thing with respect to X and then multiply by curl X by curl R. And then plus that thing here, differentiate with respect to Y and then curl Y by curl R. Does it make sense? So another way to think about this thing, you can imagine that if you have anything in the box here, in the black box here, differentiate with respect to R. So you have to do that thing to X, right? And then and then that thing to Y, right? This is in the black line here, you understand it, right? The back line here, you understand it. But now you put this thing inside the box here. This is what you actually do on this part. So you put this thing to be the black box. So it's gonna be, this is your black box. This is your black box. So this is why this term expand to this term. Does it make sense? And then now we getting to the answer. So don't look at the question now. So just look at the diagram here. If I say that I have the term in the box here, the black one on the top level, is a function of X and Y, R and S here. So it means if you want to differentiate with respect to R, so you can go by X and you can go by Y, right? And everyone understand? So it's gonna be differentiate here with respect to X and then with respect to Y, okay? So, but this time you're gonna put the thing in the box to be something called curl C by curl X. You put it in the box. So it's actually curl C by curl X here. Curl C by curl X here, curl C by curl X here. The thing in the box here, you put curl C by curl X inside there. Because what you want, this term, you want it to be here. Right? You want it to be here. So imagine that this is your box here. So it's gonna be differentiate that box with respect to X, you see that, and then time curl X by curl R, and then plus differentiate that box by Y and then curl Y by curl R. This is actually this term. 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 This is actually term. It match, right? 1 1 1 1 here. But what this one you don't use the notation here, like you don't do this. It is weird, like with people trying to make sure that we x here, sorry. So we do it this way. Because we don't do it this way, this is a little bit odd notation, so we're gonna do it this way.
แล้ว z กับz by x คือมันอันเดียวกัน is it the same หมายถึง
This, oh, they are not the same, but they are on the same level because it contains c's, so it's on the top level. So they're gonna be more practice problem on the mock exam, so don't worry, but it's gonna be the hard question on the final. So for people who want to shoot for A, so you have to look at the mock exam, and then they're gonna be the O exam that I used for BB Tech student last year to put it on the mock exam, so you can see the similar question that you're gonna see on the exam this year. Sense?
For me, this one will be the hard. For you, it's a hard question.
Well, this is usually the hardest question for derivatives test. Yeah, like on the total question about differentiation in two dimension. This is the hardest one. Yeah. Because it need you to integrate a lot of techniques like product rule, chain rule in one question, and higher order derivative as well. Okay. So we're gonna delete it here. So we're gonna practice more when it's come to the mock exam, everyone. But here we're gonna just, actually, if you want to simplify, you can do one more. You can get to, you can group this thing together to be that. Okay, group this one together. And then you can group this thing together. And then you can delete that number one. So this is actually the answer. Yeah. So again, heavy calculation because it's like super complicated in terms of notations. All right. We're gonna stop the chain rule here, and next Monday we're gonna do max and min question, max and min problems. All right. Well, you can stop here. The plan is that next Monday we're gonna do max and min problems for 2 dimensions, and then for Monday, and then Wednesday we're gonna start integrate a little bit, and then we're gonna have a Songkran break for the following Monday, April 10 and 12. The class cancel, so we're gonna have Songkran break, and then we come back on the April 19.
คือฟัง17ปะ
คือปกติวันที่10กับ12